Hey Debbie.
Hey, Chris.
Hey Ray, how you doing?
Good. Let me, were you the one that set this up?
Actually, Debbie's the administrator, so she has access right now.
So she gave you access?
No, I am just a viewer at this point.
Okay.
And I'm hoping for a good turnout. I saw your note about the UGA shortlist presentation at 10 a.m.
No, it's 10:30.
Okay,
I think it's 10:30.
perfect.
I'm going to share the screen. Let's see what happens here. Hmm. Oh, there it is. Can you see that?
I can.
Okay, so we're up and running.
Perfect.
Maybe I should update it. Let's get back to that. How do I get out of that? Oh, we'll just leave it. We're not going to worry about it. All right, well, I'm going to mute.
Okay. 10 minutes out. Good morning, Scott.
Hey, how's it going?
It's going good. How are you?
Doing okay. I'm actually Bijan. Scott will be joining me here very shortly.
Okay, perfect.
Sounds good.
Hey, Raymond, can you hear me?
Yes.
Can you guys let me know if you can hear me?
I can hear you fine.
Okay, Raymond, if you're talking, I cannot hear you.
Oops.
Good morning.
Um, hmm.
Test. I can hear Ray. Can everyone hear me?
I can hear you.
Chris, we can hear you. I can hear everybody, including you, Debbie, but she can't hear me.
Debbie, Ray can hear you. Got, can you hear Ray speak? Or Vern?
Hey, Debbie, can you hear me?
Debbie, I don't think anyone, I don't think you can hear anyone. Vern, can you hear Ray speak?
Yeah, I heard him earlier. Hey, Ray.
What about Casey?
Yeah, I can hear Casey. I hear everybody else.
Okay. Casey's on mute, and I don't know who this 01 ARC is.
I can finally hear you, Raymond. So I was trying to see if we have everybody who signed up on here.
Well, I'm picking up everyone just fine. Maybe I just need to talk louder. Let's see.
You're good. I can hear you now. I just wanted to make sure that we could record this session. So I needed to be able to hear you.
All right.
So I've made you the host. So you have all the controls now to do what you need to
Okay.
do.
All right. So it's mine.
It is. It's all about you.
It's always been about me. So we'll just continue on that with that thought. I'd like to thank all of you. It's kind of a small group today for this little presentation of anatomy of a building envelope failure. I'm Ray Ramos. I'm the president of Raymond. Just a little bit of history because I don't have a tremendous amount of time this morning. We got notified on Monday of a shortlist presentation at 10:30, so we're good right now. Been in business since '92, started off in building envelope. The company has morphed into something a little bit different we've become more of a full service company, providing architectural, building envelope, interior design, structural, mechanical, and electrical primarily. And so about 80 people, about 7 offices in 5 states. So that's my my elevator speech, and I'm sticking to it. So this is an AIA approved presentation for those of you that need that, that certificate. If you have signed up and provided your email, then we'll be able to get that certificate to you at the end of, after the end of this presentation. So just kind of outline what this is all about. I'll just go on to the learning objectives. We're going to talk about, you know, a facility, an actual facility in which we worked. And as a result of that, can show you some of the problems that occurred on it, some of the assumptions that have been made by the ownership about what the problems were, and how these issues were identified and then corrected. So kind of give you the, you know, from start to finish on this facility. Now, this facility essentially is a neurology building in Eastern North Carolina. Pretty basic structure when you get right down to it. And here is the layout of it. Office spaces, exam areas, treatment or MRI areas, physical therapy, and then the office wing. Most of it is a 1-story building. Although where the arrow is, that is actually kind of a hole in the 2nd floor where they put the mechanical equipment. So pretty straightforward type building. And then the layout, looking at the floor plan of what this is. So any of you ever been into a doctor's office? This is pretty standard fare. Interiors, again, nothing special about it. Corridors, offices, treatment areas, sheetrock are the wall systems, floors are carpeting and or tile, drop ceilings with lighting. So pretty straightforward what you're going to see in this building. Now, the typical issue that was the issue that was run into with this client is they had wallpaper that was peeling, and they had it coming in around windows. They had mold. They weren't certain it was the roof. The thinking was it was, and or do we have problems with our windows? So the typical way you approach this is, okay, let's go out and take a look at things. Let's see where we are. Let's see where the leaks are occurring. What is it doing to the facility? And so you start off just doing a visual inspection of the interior and the exterior components. Based on that, you'll then make certain decisions on whether or not you need to do something more invasive, or if you're going to need to do other non-destructive testing such as infrared capacitance or electronic field vector mapping. And that's for the roof primarily. So the walls and windows, again, you'll do the visual inspection, but the invasive part of this can be a whole lot worse, because now we're talking about tearing out walls, the interior and the exterior, and in order to examine components such as through wall flashings. And if you're going to go into any kind of testing, in particular water testing, then you have to open some of this up in order to see how the water is entering the facility. And so there are different tests with borescope. It's less invasive, but still, again, it's something that you can use if you want to take a quick peek into cavity spaces on brick veneers, as an example. Infrared, you can use it. It may tell you something about the exterior structure. It works best probably on EIFS, where you have some insulation that can absorb moisture and would give you a better idea. Whereas with brick, you may or may not get any answers by doing infrared. The blower door testing is part of water testing. You can or you don't have to do this. usually you use that to try and mimic high wind rain events and get the water to enter in those conditions. In this case, that wasn't necessary. So we'll look at the elevations. We can see we've got primarily a brick veneer system with metal roofing, and we'll look a little closer at the metal roofing. Again, brick veneer, we've got insets on the brick, lintels that are up here, and everything seems to look fairly good. The roof, standing seam metal. If we have any architects in here, architects really don't like gutters, but we need them. So in this case, they built the gutters on top of the exterior wall so that it blended in better. So really, in essence, you've got an interior gutter in this configuration, and we'll look in more detail at that. Some of the leak areas, a lot of them were at the windows, in the vicinity of windows, and you had some hallway leaks that were going on that were close to the exterior walls. Going into some of the spaces, similar problems at the windows, and we'll take a close look at the wall system where the arrows are pointing, because really what you're dealing with here is mold. And you know, I think we always say that if you need to solve a problem, you can use duct tape. And if you need to make it look good, use aluminum face duct tape. And so this is what's being used in order to encapsulate the mold that's been developing on their walls. So, you know, field expediency, you do what you need to do. Some of the other damage, loose wallpaper, the sills are rotting and they're in various stages of deterioration. Again, more aluminum face duct tape to deal with the mold issue at windows. And then if you remove, as they did, remove some of the wallpaper, you can see how mold has developed under there. Now, typically you don't want to put wallpaper on exterior walls. That is changing a little bit, primarily because the newer facilities have, if you do a good job, have air barriers that can help control some of the moisture. It just a lot of times depends on how well these window frames are insulated, because mold will develop where water is going to condense. And these are very sensitive areas. And what happens is that it condenses under the wallpaper, which serves similar to a vapor retarder. And that's where you can get this condition to develop. You also see we've got a little rusting of the metal frame too. Roof issues weren't terribly bad. Few little details like this where bringing in a ridge flashing into a valley, and there's really no good way to handle this condition. So the typical solution is let's caulk the hell out of it and hope that that gets us through the warranty phase. The office wings and the exam rooms, typical. We have, I mentioned that the gutter system sits on the exterior wall. In some places, the downspouts are built into the wall system. In others, you've got an inset where the gutter is installed. So it matches a little bit better with the aesthetics of the wall. A few conditions exist in the wall system. We have some back out of mortar. Some cracking has developed. Not uncommon that you see this in brick veneer. We don't like to see it, but it doesn't take much for this condition to develop. Slight adjustment you might see in the foundation and you can get this. Or a failure to put in expansion joints in the wall system can also contribute to a problem like this. Also, when you look at the lintels, initially you think, well, they don't look too bad, a little bit of rust on them. But the condition, as we see down below in the photos here, we have two problems. One, there's so much water that's gotten in that it's greatly deteriorated the steel lintels, which explains the rust, and it also explains why they put the sheet metal over it so it didn't look so bad. And then a lack of weeps in the system. So we've got a couple of problems that are going on here that are probably very likely contributing to the water issues in the building. And so you go out and do this visual inspection, and now it's a case of, okay, we have a pretty good idea, but now we need to validate. And the validation is through the water testing that you decide to do. Now, there's two standard methodologies that are out there, and they're very similar. AAMA 511 came out first for testing, forensic testing. And usually what happens in ASTM will come up with their own, in this case, E2128. That organization, being a consensus organization, tends to take longer in the development of their documents. And usually they defer to organizations like AAMA to establish some credibility in the testing methodologies. So these tests are available if you want to read up on them. They have certain limitations, and primarily they were developed for new construction. We do have them for forensics, but they started off dealing with window systems, curtain wall systems on new facilities, wanted to validate whether or not they would actually work before the GC was able to leave the site. And so if you're going to use these in a forensics type scenario, these tests usually have a time, it's a time test. So you want to run it for, let's say, 15 minutes. You may be running it for under a static condition or under a dynamic condition where you've got blower units that are putting negative pressure on those systems. But it's, again, you're trying to mimic a rain event or a high wind rain event. So, but in forensics, we don't necessarily want to base it on time. We want to be able to run this test in accordance with the standard protocols, but we don't have a time limit, because a lot of times we're going to develop the leaks in the building in very short order. We might develop a leak within 30 seconds. And if the test says run it for 15 minutes, we don't want to flood the building. So all we're doing in the forensic methodology is to test it until we can mimic the leak that has been reported in the past. So there's two accepted method systems that you use. One is really a standard nozzle that you can put on the end of a hose, and it has a pressure gauge on it, because we want to work in the pressures of about 30-35 PSI. And then you have the nozzle spray racks. These are where you want to cover an area of a wall system rather than trying to put water on a very specific area. And so those are pretty standard methodologies that are out there. So you know, in this case, there was no pressure chamber that was built. There was no time limit. We opened up interior walls at selected locations so that when the water test would start, we could see the water coming in. With the sheetrock in place, you may not detect that particular problem for minutes or even hours sometimes. So again, you modify the process based upon what you're trying to do. Everybody is bothering me today. Anyway, so again, it's a matter of running the test, getting set up, hanging your, in this particular case, using the spray rack system out here, and then opening up the walls, taking out ceiling grid as necessary in order to examine areas during the test. And then you can see what has been done when we get further up, hanging it off the roof in this particular case in order to run the test. You can see that we have rods on these to keep it a specific distance away when running the test. So it's a pretty straightforward thing to do. And as a result of the testing, we were able to pretty much mimic the water infiltration at the wall system. You can see some evidence of that water running down through here, and we can tell that this has been going on for some time based on the condition of this wood. And then the plywood also, again, looking up into the ceiling as in part of the interior inspection. So pretty straightforward, shows you where some of the testing was done and the basic protocols for running the test. Now the gutter. So interior gutters are very, very persnickety type systems. You have to really know what you're doing when you're installing them. As a designer, you need to make sure that certain protocols are followed in the design of an interior gutter. The first being is that the front of the gutter, like any gutter, should be lower than the back of the gutter. And on an interior system, it is imperative that you put in a secondary system that in the event that the gutter fails, that water will hit the secondary system, will be kicked out onto the brick face. The third thing we can throw in there is the type of metal that you wind up using. In this particular case, I used a Kynar finished galvanized steel. And it could have been aluminum too, but the point I would make when using this is that if you're going to use something like an aluminum or a galvanized, particularly if it's a Kynar finish, usually the only way to seal any of the joints, and there are going to be plenty of joints in here, is with caulk. And so it can work. It will fail over time, and it doesn't matter how good the caulk is, but it really requires somebody that knows what they're doing. And all too often what we see is that instead of placing the caulk between laps, they will lap everything together and then put rivets and caulk, and that's doomed to fail. Again, some of the issues with the water testing, and really what that entailed was to fill up the gutter, block off the downspouts and put water in it and see what happens. We can see water is running down the brick, coming out through the front, but it's also coming in on the interior spaces. So the gutter is part of the problem with what we've got here. And you can see in this little detail that we did that the secondary flashings aren't really doing what they're supposed to do. And if they are doing what they're supposed to do, we also learned that the through-wall flashings weren't installed correctly. But here we have a case that the back of the gutter is actually about the same height as the front of the gutter. And then we have had problems also with the connections of these drains to the bottom of the gutter. And so there's a lack of any secondary flashing. The water isn't able to come in here, come in on the back of the gutter. Once it hits the back of the gutter, it can go just about anywhere it wants to go because it's uncontrolled flow. Other problems, we wound up taking a window or two out. And this is again where construction matters. We have negative slope on the sills, and as a result, any water that's going to land on this is going to be inclined to move to the window rather than away from it. And then we have some other flashing issues, through-wall flashing problems here, which further contributed to water infiltration. Lastly, as a result of taking out the windows, found that they were incorrectly installed. window systems require caulk to be placed at certain locations. They serve as end dams primarily. If they are a drain system that then directs the water to go where they want it to go. So here we're dealing with places where it should have been installed, did not, could then flow in through the mullions at places where it was not designed to flow, and then enter into the facility because the pans at the bottom were improperly installed. So we had a number of problems that existed on this facility. It was not just a window problem. Opening up the wall system at selected locations tells us how the through wall flashing system was installed. Problems with that, we had mortar in, not bad, but it still allows water that does get in to cross over. If there's any problems with the through wall flashing, this will exacerbate that problem. Also had problems with the installation of the through wall. You typically bring it out to the outer edge, and it was not done in this particular case. And so water was able to get in through the holes at the front, which were not sealed prior to all of this work being done. And then just, you can see better here, the through wall flashing does not continue to the outside edge. The brick holes are open, and so that allows the water to move past your through wall flashing system into places where we don't want it to come out. So just a quick summary. This is the owner's complaint, and here's what we essentially found. And basically we had just wholesale problems. Sill pans incorrectly installed, missing end dams. Window construction had its own set of problems. So the installer did not install them correctly. Through wall flashing systems were installed improperly. No end dams, which led to rusting. Weep holes were missing or poorly installed. So, and then the gutters. So we had just a wholesale problem with this. So let's talk about how we deal with the problem. With the gutters, we really have two options. We can try and fix the existing gutter and make that work the way it should work. And essentially what that would entail, when you get right down to it, is take that gutter out, put in your secondary flashing beneath that gutter, lower the front of it so that if this thing overflows, it's at least 1 inch, the front end is at least 1 inch below the back of the gutter. Do a better job this connection at the gutter and downspout. So those kind of things can be done. And very likely you're going to wind up putting in a new gutter because one, you're going to fabricate it differently in order to ensure that water does not get into the wall system or the interior wall system. So you can wind up doing that. And very likely if you're going to do this, you're going to use a different metal, such as stainless steel, where with stainless steel, you can rivet and solder rather than depending on caulk. You do need somebody that actually knows how to do soldering in order to make that work, but it will work a whole lot better than trying to depend on caulk to do that. Your second option is to turn this into an exterior gutter, and takes a little bit more work, but it is guaranteed to work a whole lot better. And so that was the solution that we went with. Put in a closure, basically filled in the opening where the old gutter was, put in a closure when the gutter system was installed, and now it sits on brackets and spacers to keep it shaped. And so this works a whole lot better. Doesn't look the same as what was originally designed, but you know, us being engineers, we tend to be more interested in function than we are in looks. And just a detail to show how that was done. Now, through wall flashing systems, it's kind of the good news, bad news. One, we know what the problem is, and that's good news. Two, the solution is going to be quite expensive because now you're talking about having to remove a significant amount of brick. And in this case, we've had some very deteriorated lintels, which is going to require their replacement. So the work is going to be pretty extensive around windows. And it's just going to be what it's going to be, because in this particular case, because we had poorly installed windows, the windows are going to also have to come out. So you're going to rebuild the windows, you're going to rebuild sills, and you're going to redo your through-wall flashing systems at lintels. So a lot of work here that's required. Our Raleigh office built kind of the Bentley through-wall flashing systems. They use basically stainless steel for this. You can use a lot of different products. They all work well if installed properly. But it was a very nice job that they did. Steel lintels were painted in order to, one, protect the steel in the event it's exposed to significant amounts of moisture, and also to make them look prettier. So in this case, we actually took the architectural advice to make things look nice. And so again, we're dealing with tearing out wall systems at these windows so we can replace deteriorated wood, put in new flashing systems, and then here's your final detail where we have the sill pans, the pans in place for the windows, end dams have been installed, the through-wall flashing properly installed with end dams. Rebuilding of the sills so that we do have positive slope away from the windows to better improve their performance particularly during high wind rain events. And then some of the details that went along with the reconstruction. And here's what it looks like when done. One of the issues that you typically get into a project like this is being able to get the brick and the mortar to match up. And the older the building, the more difficult that can be. If for no other reason, you may or may not be able to get the brick from the same manufacturer. Now, what does help a lot is that a lot of these manufacturers make similar products. And so you can usually go to several and finally figure it out. And if it's not quite a match, depending on the amount of brick that you need, they can fire their ovens because they're using gas rather than wood products or coal, and be able to control their temperatures a whole lot better. And as a result, can get pretty close to the match. So you can see a little bit of it, but it's not very noticeable when you look at it from afar. You can see that we're still not done out here on this particular, when these photographs were taken. We now have, in these areas, we have downspouts that are outside of the walls rather than inside of the walls. You can see where the gutter used to be and the work that was done at the windows. So the interior conditions, basically when you start tearing these out, you're going to tear up the interior framing, and some of this framing had to be rebuilt because it had completely rotted out. Also had to do some mold remediation to deal with that particular problem. So there was literally a reconstruction on both sides of the exterior wall at the window penetrations. Some of the site work that was recommended was the trees. The trees are good looking. They really enhance the property. Unfortunately, they were filling the gutters up with leaves, backing them up on a regular basis, and they weren't performing the maintenance that they needed. So some of this, some of the recommendations was to cut down trees and or trim them so that you minimize the leaves that get in the gutters during the fall. As a result of doing this work, it required a reconstruction fairly minor, of the underground drainage system, because in some cases these downspouts were in the walls, so now they're outside, and it's just making a reconnect to the existing systems that were there. And so upon completion, you can see that for the most part, the brick looks pretty good, matches up fairly well. Blending of the mortar went well. We have that capability in these modern times to shade our mortars to get as close as possible. So that's really our last slide here. Wanted you to kind of get an idea of how we go about doing these investigations, and as a result of what we find, we also have that ability to design and manage those particular projects to completion. So at this time, I don't know who has responsibility for that. Can open up mics and we'll take questions. Does anybody have any issues similar to what was presented here? This is your opportunity to get 30 seconds of free advice. Okay, since we don't seem to have any questions, you can always submit those at a later date. You can email the host and she can get them to us and we'll respond accordingly. We appreciate the opportunity to do this presentation, and if we can help you in the future, please don't hesitate to give myself or Chris a call. Thank you very much, and you all have a good day.
Thanks, Ray. Thanks, everyone.
Thank you.